Hi students, in this video we'll discuss about Rayleigh probability density function, which is also very important in the examination point of view. Rayleigh probability density function. So if I am taking x as a random variable, then the corresponding probability density function, Rayleigh probability density function, is given by fx of x is equal to 2 by b x minus a e power minus x minus a whole square divided by b for x greater than or equal to a, and 0 for all other values of x, that is x less than a. So this is the given function for Rayleigh probability density function, and a and b are constant value, real constant values which lies between minus infinity to plus infinity. Okay, and b is always greater than 0. Now how to calculate the distribution function? So as in the previous cases, so the distribution function and the density function are related with the property of fx of x is equal to minus infinity to x fx of x dx, but this given density function is valid only for x greater than or equal to a. So that's why we can take this integration from a to x fx of x dx. So now we can substitute here a to x 2 by b x minus a e power minus x minus a whole square divided by b dx. Okay, so now this is fx of x, and again we need to simplify this. So for this I am taking x by x minus a whole square divided by b is equal to a dummy variable y. So I am taking differentiation on both sides, then you can get 2 into x minus a by b dx is equal to dy. Okay, so now substitute the values here. 2 by b x minus a dx, the total term is replaced by dy. So therefore the term fx of x is equal to integral. So if you substitute x is equal to a, then the limit is going to start from 0 to here it is going to be y. From this expression we can take, so 0 to y e power minus y dy. Okay, so integrate the terms, so then this is going to be e power minus y. So here you can take y is equal to x minus a whole square by b 0. So the limit y is replaced by the value x minus a whole square by b. So now I can take the simplification process, then you can get e power minus x minus a whole square by b. So this is fx of x. Okay, so then final expression for this fx of x for different conditions is taken as we discussed in the previous video. So the value of distribution function is 0 for x less than a. If you substitute x is equal to a, then from this expression you can get this condition. So then 1 minus e power minus x minus a whole square by b for x greater than or equal to a, and 1 for x is equal to infinity. So this is the expression, generalized expression for this Rayleigh distribution function. So now we can take graphical representation for this Rayleigh distribution function and Rayleigh density function. So with respect to the given functions, if you take the value for different values, then the Rayleigh distribution function and density functions are shown here. So this is the density function representation you can get. So here this is starting value a plus root b by 2, and the maximum value of this density function is 0.607 root 2 by b. So we will calculate this value also, no problem. And if you take the distribution function graph, so it's like this. The maximum value is 1 as x is approaching infinity. So you can take this as 1. So initially you can do this from here, a value. So I can redraw this graph. If I'm taking this as a, so from here only you can get this. Okay. And the other values a plus root 3 by 2, and this is going to be 0.393 x. So this is dense distribution function of the Rayleigh function. Okay. So this is a graphical representation. Now, how to calculate this maximum value? Maximum value of the Rayleigh probability density function, and if you have that value, you can get this value for distribution function. Let us see the maximum value here. So now we'll calculate maximum value of Rayleigh probability density function. So now we have the Rayleigh density function as 2 by b x minus a e to the power of minus x minus a whole square by b for x greater than a, and 0 for x less than a. So this is the given Rayleigh function. So now for this function, we need to calculate maximum value, at which point of x you are going to get maximum value. So the condition for getting maximum value is maximum value occurs at d by dx of fx of x is equal to 0. So when the differential of the given density function is equal to 0, then you can get the point at which the function is going to be maximum. Okay, then I'm taking d by dx of the given function fx of x. What is that? 2 by b x minus a to the power of minus x minus a whole square by b is equal to 0. And try to differentiate the terms, then you will get 2 by b x minus a. So you can take uv functionality. So then e power minus x minus a whole square by b. So now you can differentiating the terms again. This one, that is going to be x minus a minus 2 by b plus e power minus x minus a whole square by b is equal to 0. Okay. The next, so here e power minus x minus a whole square by b is a common term in the two terms. Okay, so you can take common 2 by b e to the power minus x minus a whole square by b. So then here x minus a into x minus a whole square by b. Already minus 2 is there, so minus 2 plus 1 is equal to 0. And you can make this total term is equal to 0, and the remaining term is minus 2 by b x minus a whole square plus 1 is equal to 0. So then you can write 2 by b x minus a whole square is equal to 1. Okay, so this one is going to be x minus a whole square is equal to b by 2, and you can write this as x minus a is equal to square root of b by 2. So then x is equal to a plus root b by 2. So this is the value of x at which you are going to get maximum value of the Rayleigh probability density function. Okay, therefore the maximum value occurs at x is equal to a plus root b by 2. Okay, so now how to calculate the maximum value of the density function? So just got the value, the point at which the function is maximum. So what is the maximum value? So now I'm going to substitute this value of x in the given density function. Therefore, the maximum value of fx of x is, so I can write this as fx of x maximum value. Max indicates maximum value. So 2 by b, what is the given function? 2 by b x minus a. So now x is equal to a plus root b by 2 minus a. So this is the function x minus a. So I'm just replacing x by a plus root b by 2 e power minus x minus a. Again here also x a plus root b by 2 minus a whole square by b. So then what happens? Here the plus a minus a gets cancelled. Again here also the same thing is going to happen. And this is 2 by b. What is this? Root b by 2 e to the power of minus root b by 2 whole square, means it is going to be b by 2 only, b by 2, and here we have b. So then what happens here? So b square root of b and root b gets cancelled. Then what you can write this as, what happens here, root of 2 by b, the term becomes, and here b gets cancelled, e power 1 by 2. Okay, so finally if you take e to the power of minus 1 by 2 simplification, the maximum value is fx of x maximum is going to be 0.607 root of 2 by b. So this is the maximum value what we have taken in the graph for Rayleigh probability density function. And when you take the applications of this, when you take the applications of Rayleigh probability density function, so generally this Rayleigh probability density function describes the envelope of white noise, and this describes only when the noise is passing through band pass filter. Okay, and at the same time some type of signal fluctuations received by the receiver are also be modeled by Rayleigh distribution function. Signal fluctuations by the receiver are modeled as Rayleigh distribution function or Rayleigh distribution simply. Okay, so this is about Rayleigh probability and distribution functions. Thank you for watching.